Hello, my fellow viewers. Welcome to Mr. Wanyoike, the digital learning platform. In front of you is Mr. Wanyoike himself, a mathematics teacher. In today, we are on probability. And before I tackle the probability topic, I'm going to define some of the terms. Some of the terms used, we have probability, and probability refers to a numerical measure of a chance or likelihood of an event taking place. And therefore, what is probability? Probability is a numerical measure of a chance or likelihood of an event taking place. And away from the definition of probability, there are two types of probability. We have the first one, experimental probability, and the second one, we have theoretical probability. And as far as probability is concerned, we also have a range of probability or probability range. The range of probability normally ranges from it ranges from a value greater than 0, but to a value which is equal to 1 or less than 1. And therefore, the range of probability it ranges from a value greater than 0, but to a value which is equal to 1 or less than 1. What is a probability space? A probability space refers to a list of possible outcomes. A list of possible outcomes in an event is what we refer to as the probability space. For example, what is the probability? If I have a coin and I toss a coin, there is a coin here, and this coin I have the tail. The tail is on that side, and also I have a head on this side. And therefore, the probability space of this coin, whenever it is tossed, it is head, and the second one is a tail. And therefore, the probability, there are only two possible outcomes. You can either get a tail or a head. You can either get a head or a tail whenever this coin is tossed. And therefore, the probability space of this coin, whenever it is tossed, it is either a head or a coin. What about the total probability? The total possible outcome, I mean. The total possible outcome, whenever this coin is tossed, the total possible outcome is 2. Why? Because there is only one tail and only one head. And therefore, one tail plus one head will get 2 possible outcomes. That is a head and a tail. Having said that, I'm going to define what is an outcome. An outcome, it is the result that comes out in any event during probability, and therefore the possible the possible results is what we refer to as an outcome. And as far as events are concerned, we have mutually exclusive events, and also we have independent events. So what is a mutually exclusive event? A mutually exclusive event, it is the type of event which, when it occurs, it excludes the occurrence of another event. And therefore, for example, if I toss this coin, one of the outcome, when the tail shows up, if I get the outcome as the tail, then the head will not appear. And therefore, tossing of the coin once is a mutually exclusive event. Why? Because if you get a tail, you cannot get a head, and vice versa. Likewise, if you get the head, you will not get a tail. And therefore, that is a mutually exclusive event. What about the combined event? The independent event. On the other hand, independent event refers to as the type of event when one event occurs, does not influence the occurrence of the other one. For example, if the event A is independent event to event B, it means that when A occurs, when the event A occurs, it will not influence on the occurrence of event B. And therefore, to the first example here, I'm going to deal with the experimental probability. experimental type of experimental probability. And in our first example, one, we have what is the probability of getting ahead when a coin is tossed. I repeat again, what is the probability of getting ahead when a coin is tossed? And therefore, I'm going to do it practically. I'm going to toss this coin. And when I toss this coin, I toss it, then I have gotten the head. You can see the first tossing is giving me the head. What about if I toss it again? Good. You can see that the second outcome is a tail. And therefore, you can see that both events are mutually exclusive events. Why? Because in the first tossing, I only got a head and the tail did not show up. What about in the second tossing? In the second tossing, I have only gotten the tail, and therefore the head has not shown up, and therefore that kind of event is what we refer to as mutually exclusive event. Okay, back to the question. How do we get the solution to this? You can come up with a tree diagram. You can draw a tree diagram, and you draw a tree diagram, and you will see a head there, and you will get a tail there, and this is the outcome. This is the outcome. You say that is the head. This is the outcome. That is the head, and therefore these are outcomes. So we have a head, and the second one, sorry, should be a tail. Therefore, the probability of getting a head is a half, 1/2. Why? Because there are only one occurrence of head whenever a coin is tossed, and also the one outcome for tail as far as a coin is tossed, and therefore the probability space is H and tail. And what about the total possible outcome? It is 2. The total possible outcome is 2 because we have a head and a tail, and therefore as far as head is concerned, you have 1 out of 2 outcome. And what about as far as tail is concerned? It is also a half. So the probability of getting ahead as far as this question is concerned, you will say it is a half. Why? Because there is only one favorable outcome. That is, the head is favored only once out of 2 possible outcomes, and therefore the probability of getting ahead is a half. What about in the second example? In the second example, I'm going to illustrate it using an experiment, and assuming that I have actually, it is not assumption. It is something which is a fact. I have a bucket here, and this bucket does not have anything else. It is empty, and therefore I have also with me, I have 5 types of pens here. So we have 3 of them are black, and 2 of them are blue. So as far as these 5 pens are concerned, you can see that 3 of them are black and 2 of them are blue. And therefore, what is the probability space? What is the probability space? So the probability space as far as this example is concerned, I have 3 black pens and 2 blue pens. And therefore, as the question states, the question you are told, you can read it very well from the diagram. The question reads, a bucket contains 2 blue pens and 3 black pens. All pens are identical in size and texture, except for colors. Use this information to answer the following questions. The first question is the probability space. The first question is the probability space. And as far as the 5 pens are inside the bucket, the probability space, I have said it is supposed to be 3 there are 3 black pens and 2 blue pens. That is the probability space. What about when it comes to and therefore I will just definitely light the probability space as far as this question is concerned. I will light the probability space is supposed to be 3 black and we have 2 blue pens. So we have that is the probability space. We have 3 black and black pens, and I have also 2 blue pens. And therefore, what about the total possible outcome? What is the total possible outcome? The total possible outcome should be 5. The total possible outcome should be 5. Why? Because I have 2. We have 2 blue pens, and also I have other 3 black pens, and therefore the total possible outcomes is 5 because I have 5 pens inside the bucket. And therefore you may be asked in this question, you will be asked, what is the probability of picking a blue pen? And therefore, when it comes to the probability of picking a blue picking a blue pen should be given by what? The probability of picking blue pen, picking a blue pen. How do we calculate it? I can go back to the question demonstration. You can see that there are 2 blue pens and we have 3 black pens, and therefore the probability of 2, the possible favorable outcome is supposed to be 2, because in this case I'm referring to the blue pen, and therefore the total, in order for you to get the probability of any event, you are supposed to calculate it by using the total favorable outcome. You divide by the total outcome, and therefore the favorable outcome in this case is supposed to be blue, and in this case there are 2, and you divide by 5. You divide by 5 because total number of pens in the bucket are 5, because we have 3 black and also 2 blue pens, and therefore the probability of picking a blue pen should be 2 over 5. Why? Because the favorable outcome is a blue pen, and since there are 2, the numerator becomes 2 and the denominator becomes 5, because the total number of possible outcomes should be 5. Having said that, those 2 examples, I have dealt with them in an experimentary way. I've done an experiment and I have demonstrated what is all about experimental probability. Having said that, I will come to the second aspect, or the second type of probability, and that is theoretical probability. So there is a question here which will help us understand the concept of theoretical probability. And in this question, you are given this question here. You are told that a boy had a fair die with faces marked 1 to 6. He drew his die up to X times, and each time he recorded the number. He recorded the number on the top of the top face as shown below. So he was recording. You can see that face number 1, the total number of outcome were 11. Then face number 2 appeared only 5 times. Face number 3 appeared 7 times. Face number 4 appeared 10 times, and face number 5 occurred 9 times, and finally face number 6 occurred 8 times. And therefore the question you are asked, you calculate the total possible outcome. What is the total possible outcome? What is the total possible outcome? What is the total possible outcome? The question is supposed to be what is the total possible outcome? What is the total possible outcome? Total find the total possible outcomes. What are the total possible outcomes? And as far as this question is concerned, we are going to stress so much on the number of time a phase shows up, and that is the frequency. And therefore, you are going to get the total possible outcomes is given by 11 plus 5 plus 7 plus 10 plus 9 plus 8. And therefore, if you add all of them, 11 plus 5, that is 16, 16 plus 7, you're going to get 23. 23 plus 10, you get 33. 33, you add 9, you get 42. And 42, you add to 8, you are supposed to get the answer as 50. And therefore, it means that the letter X here, is represented by 50. It's representing 50 times. So if you ask what is the total number of times the die was drawn, you are supposed to say 50 times, and therefore that is the total possible outcome. The second question you are asked, probability of getting the phase number 4. And therefore, as I said in the other question, in the previous example, probability of an event is given by the formula favorable, number of favorable. You write number of favorable outcome, you divide by total outcome. Number of favorable outcome, you divide by total number of outcomes. So here you will be having, as far as 4 is concerned, the favorable outcomes are 10 because the frequency is 10. And therefore, number 4 showed up 10 times. And therefore, you will write 10, you divide by the total number, which was supposed to be 50. Then you will get the answer as 1 over 5. So the answer, as far as the answer is concerned, you are supposed to get 1 over 5 being our answer to that question. And therefore, you will cancel 0 and 0, and therefore you will be left with 1 over 5. And therefore, the probability of getting phase number 4 should be 1 over 5. What about another example? As far as example number 3 is concerned, it is an independent event. It is an independent event. And I said independent events, it is whereby the occurrence of one event will not influence the occurrence of the other event. And having said that, I will go to example number 4. And in our example number 4, you can see it very well. It is well illustrated. You are told 2 fair dice are tossed simultaneously. Find the following probability. The probability that the sum of dice X, we have the die X and die Y, and therefore the sum of the probability that will give us the sum of 7. You can see that in this case there is a 7 here, and therefore the sum that will give us 7, we are going to use Punnett square. We work with the die Y, and also we have the die X. And therefore, as far as the answering of that this die is concerned, we'll say X plus Y, 1 plus 1, you will get 2. 1 plus 2, you will get 3. 1 plus 3, you will get 4. 1 plus 4, you will get 5. In that order up to 7. What about 2 plus 1? 2 plus 1, you will get 3. 2 plus 2, you will get 4. And therefore, you increase by 1 each and every time that way. And 3 plus 1, you will get 4. Then you increase by 1 each and every step like that. 7, 8, 9. What about 4 plus 1? You will get 5. Then you increase by 1. It becomes 6, 7, 8, 9, 10. What about 5 plus 1? 6. 5 plus 2, 7. You increase by 1, 8, 9, 10, 11. What about 6 plus 1? It is 7. 6 plus 2 is 8. You increase by 1, 9, 10, 10 there, 11, 12. And therefore, you can see that whatever I've written here, they are the results, they are the possible outcomes. The total possible outcomes are how many? They are supposed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And therefore, the total possible outcomes are supposed to be 36. And as far as 7 is concerned, the sum being 7 is concerned, we have the first one, 7, the second one, the third one, the fourth one, the fifth one, the sixth one. And therefore, you will find that as far as the sum of x plus y is concerned, the probability of getting 7, probability of getting the sum of 7, the probability of getting the sum of 7, I will write it this way. The probability of sum, you can write the sum, the probability of x plus y is equals to 7 should be given by how many 7s are there? 1, 2, 3, 4, 5, 6. It is supposed to be 6. What about the total possible outcome? They are supposed to be 36. And if you simplify, you will get 1 over 6. And therefore, that is the solution to that. What about the probability of x plus y is equals to 5 or 7? What is the probability of that? And therefore, as far as that one is concerned, I will also include the 5, the sum being 5, the sum of x plus y being 5. So I have 5 here, 1, 2, 3, 4. How many 5s? There are 4 5s. 1, 2, 3, 4. What about 7? 1, 2, 3, 4, 5, 6. So if I count all of them, I'm supposed to get the probability of 5 or 7 is given by the probability of 5 or the probability of 7. And therefore, the probability of 5, they are how many? 1, 2, 3, 4. They are supposed to be 4 out of 36. What about 7? They are supposed to be 1, 2, 3, 4, 5, 6. 6 out of 36. And therefore, if I add the 2, I will get 10 over 36. And if I simplify, I get by 2, 5, by 2, 18. So the answer becomes 5 over 18. And therefore, as far as that one is concerned, the answer is that. What about the probability? What about the probability of x plus y, where x plus y is greater or equal to 7? What is the probability of that? And I'm going to look for the values which are equal to 7 and greater than 7. And therefore, equal to 7, I have how many values? I have 1, 2, 3, 4, 5, 6. Also 8. Also 9, also 10, also 11, also 12. Also all this, in this region, actually, this region is the result. The result lies under this region. The result lies under that region. And therefore, I'm supposed to count for all values because these values are equal to 7 and also greater than 7. And therefore, I count all of them. And therefore, what is the value? What is the value do I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I will count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So it's supposed to be 21. You divide by the total possible outcomes is 36. By 3, 7. By 3, you will get 12. And what is the answer? The answer is 7 over 12. And that should be the answer. What about the last question? And as far as this question, Roman 3 is concerned, you may be asked, what is the probability that the sum of x plus y is at least 7? So it can be written this way, or you are asked at least 7. What about this one? You can also be asked, what is the probability that the sum of x plus y is at most 5? This way means at most 5. And therefore, the probability of at most 5 is equal to what? I'm supposed to count the values where we have 5 and a value less, the result which is less than 5. And therefore, in this case, I will look on this region whereby I have the 5 and I have also the other values which are less than 5. And therefore, I have 1, 2, 3, 4. 5, 6, 7, 8, 9, 10. And therefore, as far as less than 5 is concerned, I'm going to say that there are 10. There are 10 favorable outcomes out of 36. And by 2, I get 5. By 2, I get 18. And therefore, the answer is 5 over 18. And therefore, that marks the end of my lesson today. Your presenter was Mr. Wanyoike, a mathematics teacher. Till next lesson, bye-bye.